We're going to walk through the circuit from lab and how to do the error analysis for the measurements that you took in lab. All right, and so we're going to go through the lab again just to get all the pieces down. So we had 6 resistors, R1, R2 and R3 in series, R4, R5 and R6 in series. And the first thing we wanted to do in trying to simplify this circuit and because our goal, of course, is to figure out the voltages across every single resistor, And we're going to do that by reducing the circuit down, finding the current, and then working our way back out. So the first step, of course, is combining R2 and R3 and combining R5 and R6. And since they're in parallel, they combine by adding the inverses and inverting. So I'm just going to go over, I'm going to make up some numbers. Let's do R1, R2, R3, R4, R5, and R6. I'm going to make up 1800, 2400, 2000, 1900, 2200, 1600. All right, so combining R2 and R3 to get R23, what are we going to do? We're going to take 1 divided by R2 plus 1 divided by R3, and then we're going to take the inverse of that, and that's going to give us R23. The same thing can be done down here. Now that's R56. All right. So that puts us where? That puts us right here. All right. R23, R56. Now we've got to make this next step to go from this circuit to this one, which just means combining these 3 resistors that are in series. So R2, 3, 4, 5, 6 is just R2, 3 plus R4 plus R5, 6. All right, so now we're at this circuit, and we've got to make the final little step. We're going to combine R2, 3, 4, 5, 6 and R1. They're in parallel, so we're going to take the inverses of those. All right, and so here we go. Our total is 1 over R1 plus 1 over R2, 3, 4, 5, 6 to the inverse. So the total resistance of this circuit is 1233.291. The 0.291 doesn't matter at all. Okay, so now we know the total resistance. All right, everything here is being done with calculations. It's being done with calculations for a reason, because we're going to have to play with these values and the errors on them to figure out where things are. Now, the other value you have that's a measured value was the voltage. I'm going to put in 10.31 volts here just to put in a voltage. So we now know the voltage, we now know the total resistance, so we know I total, which is just going to be the total voltage divided by the total resistance. Okay, so now we've made it all the way down to here. We know our total, we know I total, and we start working our way back out. All right, I 2, 3, 4, 5, 6 plus I1 has to be equal to I total. Well, I1 is just the voltage divided by R1. So I'm going to go over here, calculate I1, which is just going to be the voltage divided by R1. And then I 2, 3, 4, 5, 5, 6 is just I total minus I1. All right, that puts us right here. All right, we make this step. We're going to expand it back out once more to R2, 3, R4, and R5, 6. All of these have the same current running through them. And we know, because they have the same current running through them, that V23 is I2, 3, 4, 5, 6 times R23. and V56 is I23456 times R56, and V4 is I23456 times R4. But the other thing we know is since R2 and 3 are in parallel, they have the same voltage across them. So once we know V23, we know V2 and we know V3. And once we have V56, we know V5 and we know V6. So we just need to do some little multiplication here to get the other voltages. All right. So I'm going to put in, since we need it, this V1 is simply the voltage we have. V23 is I23456 times R23. V56, or nope, V4 is the current times R4, and V56 is the current times R56. And this is also V2 and V3, and this is V5 and V6. So now we have every single measurement you made. You measured V1, you measured V2 and V3, you measured V4, and you measured V5 and V6. And what we want to do is look at how do we propagate all the errors through to figure out what's the error on this. All right. Now, this is going to be work, and it's going to be work because we have 6 different things to worry about. All right? 6 different things to worry about. I'm going to copy these. Put them down here. So we have to go up a percent. Remember, they're all 1%. Oh, 1% times 0.01. All right, that minus, I don't know why I'm doing it this way. Let me do this. Equals that times 1.01 equals that times 0.99. And now I just copy that down. All right, so this is the high value, low value. Add another. Okay. So this is a lot of work just from the combinatorics, right? And what we're going to do is we're going to go through and we're going to figure out the error due to R1. We're going to figure out the error due to R2, and the error due to R3, and the error due to R4, and R5, and R6. And we're going to do that sequentially, and we're just going to worry about one at a time and record that so we don't have a million things in a spreadsheet. Because all of these errors are independent of each other. All right, R1, the error on R1 has nothing to do with the error on R2, etc. So I'm going to go up here. We've got a central value on all of these. 10.31, 2.87, right? That's our central value. And we need to find out what happens when we mess with these values. I'm going to copy everything once because we need to keep our central value going. Okay, now I've turned my mail off and we have our copy of everything we did up above. And we've got our highs and our lows, and what we're going to try and do is sort out what's the variance on each one of these due to the different resistors. So how do we do that? Well, it's pretty simple. 1818. Okay. All right, let me go through this. I'm going to go back to 1800. Well, it helps if I go here. Go back to 1800. All right. I'm going to copy the central values and paste them as values. So we've got those. And then I'm going to do 1818. All right, so V1, there's no variance. Why? Because V1 is the source voltage. But here we've got no difference, or not enough to matter. 1800, 1818. Okay, not enough to matter. 1782, not enough to matter. Oh, yes, right. Because no matter what we do, it's just affecting a little bit the current going through the other. So 1800. So there is no variance due to R1. Now, 2424. Now we get some variance, right? So what do we have? This minus that. All right, so that's the variance. Paste the values. Due to going down up, let's go down 2376. All right, and that's the variance. And so I'm going to say equals 1/2 times the absolute value, or not the, yeah, I need the absolute value, average, because, nope, not average. 1/2 the absolute value of the difference. Lord. So, all right, so this is the variance in these voltages due to R1. All right. Tell you what I'm going to do. I'm going to pause this video at this point, or stop this video at this point, because it's getting kind of long. And we're going to start a part 2. And I'm going to set up just a little bit differently so that we can record these a little bit better. But here we go. This is sigma due to R2, right? That's the error due to R2 on those quantities. All right, give me just a second. I'll be back with another video shortly.